Welcome to Talkcast and to part 2 of my discussion of chapter 12 from the Fabric of Reality, Time Travel. And today we're going to get into some of the paradoxes or apparent paradoxes associated with time travel and how the four strands that are so often talked about today with respect to the work of David Deutsch come together for us to really understand what's going on with the actual physical possibility of time travel. And what kind of problems might be associated with thinking about going into our past? What knowledge has to do with time travel? There are three aspects to David's discussion of time travel, two of which we have touched upon already in part 1. The three aspects are trying to accurately render what it might have been like in the past, that is an image generation of past times, a virtual reality rendering of past times and what additional problems that might introduce, because after all, if you are interacting with past figures from history, then you are changing the way in which the environment would have responded. And then finally, there is the physical possibility of actually traveling into the past. What would virtual reality have to do with that? Well, that's to do with the universality of computation. Virtual reality, remember, gives us an important insight into what it is physically possible to do. After all physically possible processes are computable. So therefore, if we couldn't render the past in some way, then it wouldn't be physically possible to go there and change it. Today's episode, as you can already tell, is experimental in a sense. Once again, I am outside. It's rather a windy day, but hopefully this audio equipment doesn't pick up too much of that. But you may be able to hear the waves crashing in the background of the bay that I happen to be next to. For astute fans of Talkcast, you may realise that I am in a very similar place to where I was for part of my Beginning of Infinity series of discussions, in particular chapter 3, The Spark, part 1. I was sitting outside in roughly the same place, and that's kind of useful for today because, as David Deutsch explains, time machines are better thought of as special places rather than vehicles. And this idea of a time machine being a place rather than a machine that is travelling through space, because it's not. In theory, it's going through time, but if you're going from one time to another in the same place, rather than moving from one space to another space, then you don't really have a travelling machine. You have a special place that transports you to a different universe. But we will get there. The paradoxes of time travel that many people are aware of, David will discuss. Things such as the so-called grandfather paradox, where you go back in time and you kill your grandfather before they have a chance of giving birth to your father. And so therefore, you were never born, you could never have gone back in time through the time travel machine to kill your grandfather. That appears to be a paradox. There are multiple such paradoxes. Just go Googling different time travel paradoxes. The overwhelming majority of them are completely solved by thinking of physical reality as a multiverse. And once you do that, once you realize that there are many fungible instances of you right now, and all physically possible paths can be taken, then the paradoxes are resolved. Because if you can travel back in time to when your grandfather was, who you are meeting is not your grandfather as soon as you interact with them. Because as soon as you do that, in fact, as soon as you are there in that universe, you have changed that universe in some way, and that universe ceases to be the one which leads to you going back in time. You are part of a different timeline, a different series of universes, if you like. It's all the one physical reality, and there can be no contradictions in physical reality, so therefore there can be no paradoxes. There can be a problem, however. The problem is to do with epistemology, and we'll get to that at the end of today's episode. That is the part of this chapter that I personally find most interesting of all, because there you have unresolved problems, and you have a deep insight into where knowledge comes from. I like to say, and as David has said before, knowledge creation is literally a form of creation. Literally a form of creation. In other words, it's not there antecedent in anything that has gone before. It comes from nowhere. And I find those far more interesting than the so-called paradoxes of time travel like this grandfather paradox, which actually have solutions. The only reason they appear as problems for other people is because they do not think in terms of quantum theory. They're not thinking in terms of the multiverse. They're thinking in terms of single universe classical physics, whether it's Newtonian or Einsteinian, it doesn't matter. Paradoxes arise there. And if there was only one universe or one series of universes, if you like, and you went back in time and you killed your grandfather, yes, that would be a problem. But it's not a problem in physical reality because physical reality does not consist of a single universe. So let's get into the reading where David begins to explain the most basic of the paradoxes. And he says, quote, "Here is a typical such paradox. I build a time machine and use it to travel back into the past. There I prevent my former self from building the time machine. But if the time machine is not built, I shall not be able to travel into the past, nor therefore to prevent the time machine from being built. So do I make this trip or not? If I do, then I deprive myself of the time machine and therefore do not make the trip. If I do not make the trip, then I allow myself to build the time machine and so do make the trip. This is sometimes called the grandfather paradox and stated in terms of using time travel to kill one's grandfather before he had any children. And then if he had no children, he could not have had any grandchildren, so he killed him. These two forms of the paradox are the ones most commonly cited and happen to require an element of violent conflict between the time traveller and people in the past. So one finds oneself wondering, who will win? Perhaps the time traveller will be defeated and the paradox avoided. But violence is not an essential part of the problem here. If I had a time machine, I could decide as follows, that if today my future self visits me having set out from tomorrow, then tomorrow I shall not use my time machine, and that if I receive no such visitor today, then tomorrow I shall use the time machine to travel back to today and visit myself. It seems to follow from this decision that if I use the time machine, then I shall not use it, and if I do not use it, then I shall use it, a contradiction, pausing there my reflection. And I am stealing the punchline here. But if you pay attention to the previous 11 chapters of the Fabric of Reality, you should be able to reason your way to the solution. Now, I didn't do this. I fully admit that I wasn't capable of doing this when I first read the Fabric of Reality. And I think that chapter 12, Time Travel, should, if you find it confusing, be read in conjunction with the Beginning of Infinity chapter on the multiverse. Because it is in the multiverse chapter of the Beginning of Infinity that we learn about fungibility. As I sit here now, if tomorrow, just as David says there, if tomorrow I was able to build a time machine, travel back to today and prevent myself from ever building the time machine by tying myself up or whatever it happens to be, then I couldn't possibly come back, could I? Well, of course I could, because as I sit here now, I am not a single copy, a single instance. I am many instances that are differentiating, going off to do something else. And David says very early on in the Fabric of Reality, he talks about making a cup of tea. You know, he might sit and write the book, or he might go off and make a cup of tea. Every physically possible thing that he could do is actually done somewhere in the multiverse. Not to equal measure, but everything that could possibly be done is done. So, if tomorrow I build the time machine and then I travel back in time to now and meet myself, I am not meeting the actual Brett that built the time machine tomorrow, but a different version. The version that I meet here and now, having traveled back from the future to now, is someone different. It's a copy of me, identical in almost all respects. They may go on to build a time machine, or they may not, but that has absolutely no bearing on the fact that I already did build the time machine, because there are many different versions of me doing many different things, only some of which, in fact, the majority of which, if indeed I do go and build the time machine, do build the time machine. Some go off and make a cup of tea, some go for a swim in the bay behind me, some do get tied up by the copy of me that comes back, some spontaneously combust, some turn into a rabbit, some turn into a series of butterflies and fly away. All of these things happen. But the point is, none of them can prevent the creation of the time machine that already happened in the future. That's already happened. That's fixed, if you like, in physical reality, by the fact that, in fact, it was used to come back to this time. Although there is a problem with all of this, which is you can only travel back to times when the time machine actually existed. Now, if the time machine doesn't actually literally get created until tomorrow, then it can only possibly be used to travel back in time to any time after tomorrow. So in other words, build it tomorrow, wait a month, and then you can go back to a month prior. We'll get to these particular details, but all of that aside, the paradoxes are completely fixed by Everettian quantum theory. Because you never travel back to your universe. Your universe is your universe. And that's it. There may be many, many identical copies of your universe, but they go off and do, well, some of them go off and do the same thing, but some do different things. And if you travel back into the past, if you're able to travel back into the past and change it in some way, it's obviously not the case that that's the universe that you once occupied, because it's different. So these contradictions are only a part of the single universe classical theory of time and space. Let's continue and see what David has to say about this. Quote, "A contradiction indicates a faulty assumption, so such paradoxes have traditionally been taken as proofs that time travel is impossible. Another assumption that is sometimes challenged is that of free will, whether time travelers can choose in the usual way how to behave. One then concludes that if time machines did exist, people's free will would be impaired. They would somehow be unable to form intentions of the type I have described, or else when they travel in time, they would somehow systematically forget the resolutions they made before setting out. But it turns out that the faulty assumption behind the paradoxes is neither the existence of a time machine, nor the ability of people to choose their actions in the usual way. All that is at fault is the classical theory of time, which I've already shown, for quite independent reasons, to be untenable. If time travel were logically impossible, a virtual reality rendering of it would also be impossible. If it required a suspension of free will, then so would a virtual reality rendering of it. The paradoxes of time travel can be expressed in virtual reality terms as follows. The accuracy of a virtual reality rendering is the faithfulness, as far as is perceptible, of the rendered environment to the intended one. In the case of time travel, the intended environment is one that existed historically. But as soon as the rendered environment responds, as it is required to the user kicking it, it thereby becomes historically inaccurate because the real environment never did respond to the user. The user never did kick it. Pausing there, my reflection. Now, at this point, David goes on to talk about Caesar and Dr. Johnson. So let me kind of reframe that in a couple of different ways. Imagine you go back in time via, well, not really go back in time, but you simulate the process of going back in time using an image generator, as David has referred to it. An image generator is like a virtual reality generator. It's just that you can only witness what is going on. You can't interact with it. Now, I'll get to why we're talking about that in just a moment. But the first problem with going back in time in this way is as follows. Let's say you wanted to go back to witness the assassination of Julius Caesar. Julius Caesar, killed by Brutus and the other members of the Senate in ancient Rome. You decide to go back to that time. The first issue we have, although it is technically, physically possible, according to the universality of computation, to render such an environment, is, as David has mentioned earlier, although I don't think he puts it in quite these terms, gathering the information required to input into the simulation, into the image generator, so that you can have an accurate rendering of what actually went on during the assassination of Caesar. Now, most of the evidence has long since been lost to history, to entropy, to erosion, and to those physical forces that have completely destroyed the information that you would need, the evidence you would need to gather in order to figure out what the Roman Senate looked like accurately, to see what the people were like accurately, not merely look like, but actually behave like, what they said, what was going on exactly at the time. So there may be that kind of physical limitation to even rendering such an environment, just to see it as a almost perfect or arbitrarily accurate movie as what those events historically looked like. There are no photos of Caesar, so how can we possibly have an idea of precisely what it looked like? Maybe we could get some of his DNA. Maybe by amazing chance some has been preserved somewhere, but genotypes will not give you the perfect phenotype. For the phenotype, we'll also need to know what he was eating, how much sun he was exposed to, all sorts of environmental factors that will affect things like how tall he got and what his skin complexion was. And as for what was said at the time between the senators and Julius Caesar as he was being murdered, all of that stuff, that information was never captured. So how could we possibly do a perfectly accurate rendering of that time? Never mind interacting with it, just looking at the series of historic events. And that is true for every single historic event. The evidence may well have been lost for eternity. So there may be no replicating it. Now, let's add the additional complication, okay, because we're just doing a thought experiment here, that even if we could gather all the information that was needed, if all the evidence was available in order to input into our supercomputer to do an almost perfect simulation of what was going on at the time, in some distant future, this is the way in which history might be learned. Rather than reading books, you actually go back in time and have a highly, highly accurate rendering via this technique. If we take it a step further into virtual reality, where you could actually talk to the characters involved. Maybe you go to Caesar's house prior to him leaving for the Senate that day to prevent him from ever being stabbed by Brutus and the rest of the senators to stop his assassination. Well, you're going back to a certain time that in fact is not part of your history. Because if you go back in time and interact with Caesar, preventing him from going to the Senate, preventing him from being assassinated, that's not your history. It is a history, it is a different history. So it would suggest that as soon as you start to change things, there will be multiple histories. And the virtual reality generator, if it is a faithful generator responding in the way that would physically happen on the basis of the way in which Julius Caesar would behave, then what you will get is a version of actual physical reality that did indeed happen, that does indeed happen somewhere in the multiverse. It's just that it's not your history and it's not your Caesar, because your Caesar gets assassinated by Brutus. And so therefore, if you go knocking on Caesar's door and say, "Hello, Julius," presumably in Latin, and actually I think some of his friends did try and dissuade him because they knew, at least one of his friends knew, that he was going to be assassinated and tried to persuade him not to go to the Senate that day, but he decided to go anyway, whatever the case. If you were successful in persuading him not to go to the Senate, and so he doesn't go to the Senate, so he doesn't get assassinated, that is a thing that actually really happened somewhere in the multiverse. And so the virtual reality rendering of the past must also be able to do that. It must be able to render, to simulate, to represent to you literally anything that could physically possibly happen. And so this supercomputer that is able to give you a virtual reality generation experience of the past would have to be arbitrarily accurate in representing the way in which Caesar behaves and everyone who was alive at the time behaves. And as I say, such a simulation, such a virtual reality generator would contain within it AGI. It would also have to solve that problem in some way. So it's going to be it's basically going to be a simulation of, well, in theory, the entire universe, because even stuff in outer space is going to be affecting the Earth and causing environmental changes and so on and so forth. So if you really want a true virtual reality, highly arbitrarily accurate simulation of what goes on historically, it almost has to be a simulation of basically the entire universe, or at least a large region of space around the Earth that could possibly have affected anything that went on in the Earth at that time. Things get complicated. And we're just talking so far about image generation, virtual reality generation, which gives us a bit of an insight into the physical possibility of actual time travel, which we're going to come to. The central point here is, anyway, the paradoxes are resolved by simply considering that the time that you go back to, although it is behind you and calendars are going to read times prior to the one in which you left, it's not your time. So as soon as you appear in this previous universe, whether it's a virtual reality journey that you take, or an actual physical journey that you take to this previous time, you're not going back to the real physical universe that you existed in. After all, as soon as you appear in that universe, which shows calendars with a time that is the past, according to you, that's not your past because you weren't there. You exist in 2025, 2026, or whenever you happen to be watching this. You don't exist at the time of Caesar. So therefore, if you go back to the time of Caesar, it's not your past, it's a different past. Permitted, yes, by the laws of quantum theory, not permitted by our classical understanding of time, where there is a single time, because that would lead to a paradox. But there is no such paradox. After all, if time travel to the past is possible, if it is possible for you to go back to the time of Caesar, then at that time, 44 BC, at that time, if time travel was possible, then what's happening on the Ides of March, the day that Caesar was assassinated, what's happening then is all the physically possible things that could happen. Caesar does everything that he could have done that particular day. The majority of the things that he actually did do that day in the multiverse are likely turn up at the Senate and get assassinated. But there are some universes where he didn't, and if time travel to that time is possible, there are some universes where time travelers have indeed gone back to those times and prevented Julius Caesar from getting assassinated, assassinating Julius Caesar themselves, any number of things that time travelers might have done. People often wonder, if time travel is possible, why aren't we seeing time travelers from the future coming back to now? Well, they might very well be coming back, but it's not you that's seeing it, but only copies of you that are seeing it, because they're not traveling back to all the possible copies of you. Okay, the copy that you're seeing right now as the copy that I am right now of myself. I know this language gets confusing, but there are many copies of yourself because there are many universes. This is the whole idea of Everettian quantum theory. If time travel to the past is possible, let's say, I don't know, as David will talk about later in this chapter, natural time machines may be possible. So there may be rotating black holes, for example. So maybe an existing rotating black hole is out there somewhere in the universe that can be used right now as a time machine and has been there since nearly the beginning of the universe. Then there could be time travelers from the future that are traveling back to the year 2025 or whatever it happens to be. It's just that not every single copy of you will be interacting with those time travelers, but some might. Some might. So we can't rule out on the basis of observation, this would be an empiricist mistake, the fact that time travel is impossible simply because we haven't seen any time travelers. That argument doesn't work. Again, the argument doesn't work precisely because there are many copies of you right now. And the copies that exist of you right now do everything that you could possibly do right now, as I mentioned earlier. Some of them might be experiencing a supernova appearing in the sky. Some of them might be experiencing an asteroid racing across the sky. Some of them might be experiencing winning the lottery. Some of them might be experiencing dropping dead. Some of them might be experiencing a time traveler from the future coming back. If it's possible, it happens. Now, I'm not saying it is possible. Okay, we don't know. I'm not saying it is possible that time travelers from the future could be coming back to visit you now in 2025, because that depends on whether or not a time machine exists, natural or artificial now. Perhaps there are aliens out there from another galaxy that invented time machines millions of years ago and they can transport it here. Okay, that might work, I'm not sure. And then they have got wormholes to travel from one place to another and so on. It could be possible, but I'm getting far ahead of myself. Let's keep going with the chapter before I confuse myself as well as you. Now, all of what I've said here is informed by not merely the fabric of reality, but also the beginning of infinity. This is why I'm animated about this. So I'm going to skip quite a sizable section here of the chapter because I've explained some of what David has already explained, and I'm going to skip to the point where David talks about these copies. Let me go back to the book where David talks about a thought experiment where he steps into a time machine. And he writes of his time machine, quote, "The environment I see around me is a futuristic laboratory." So he's imagining right now. And he continues, quote, "In the middle there is a revolving door like those at the entrances of large buildings, except this one is opaque and is almost entirely enclosed in an opaque cylinder. The only way in or out of the cylinder is a single entrance cut in its side. The door within revolves continuously. It seems at first sight that there is little one can do with this device except to enter it, go round one or more times with the revolving door and come out again. But above the entrance is a sign, Pathway to the Past. It is a time machine, a fictional virtual reality one, but if a real past-directed time machine existed, it would, like this one, not be an exotic sort of vehicle, but an exotic sort of place. Rather than drive or fly it to the past, one would take a certain path through it, perhaps using an ordinary space vehicle, and emerge at an earlier time. On the wall of the simulated laboratory, there is a clock, initially showing noon, and by the cylinder's entrance there are some instructions. By the time I have finished reading them, it is 5 minutes past noon, both according to my own perception and according to the clock. The instructions say that if I enter the cylinder, go around once with the revolving door and emerge, it will be 5 minutes earlier in the laboratory. I step into one of the compartments of the revolving door. As I walk around, my compartment closes behind me and moments later reaches the entrance again. I step out. The laboratory looks much the same, except what? What exactly should I expect to experience next if this is to be an accurate rendering of past directed time travel? Let me backtrack a little first. Suppose that by the entrance there is a switch whose two positions are labelled interaction on and interaction off. Initially, it is set at interaction off. This setting does not allow the user to participate in the past, but only to observe it. In other words, it does not provide a full virtual reality rendering of the past environment, but only image generation. With this simpler setting at least, there is no ambiguity or paradox about what images ought to be generated when I emerge from the revolving door. They are images of me in the laboratory, doing what I did at noon. One reason why there is no ambiguity is that I can remember those events, so I can test the images of the past against my own recollection of what happened. By restricting our analysis to a small closed environment over a short period, we have avoided the problem analogous to that of finding out what Julius Caesar was really like, which is a problem about the ultimate limits of archaeology rather than about the inherent problems of time travel. Pausing there, my reflection. Yes, and so this is the point. David is thinking here, as many discussions of time travel do, about the physics of just time, rather than being concerned about the physics of archaeology, for example. So the limits of archaeology are also to do with the limits of physics. Is the evidence still there, able to be collected, and therefore able to render historically what went on at the time? It also applies to books. We may not be able to get enough information to arbitrarily, accurately, wonderful phrase that we often use here, arbitrarily, accurately describe or explain what went on in the past. Why? Because there is no evidence left. It is impossible to figure out certain things, like what did Julius Caesar eat for his meal for his 13th birthday at breakfast time? There's an answer to that question. Okay, it's a real physical universe that existed, but there may be no evidence for us to ever be able to collect now. It's long since been literally blown away by the winds of time. So some things that happened we cannot know. This has nothing to do with Gödel's incompleteness theorem or anything like that, but just the universe itself has lost the information now. That information has been lost. The multiverse contains that information, but not our universe. Okay, so let's continue. I'm going to skip a little bit again. David talks about what happens if he steps into this time machine and then goes back into the past and he sees himself. Let's assume this is an image generation time machine. So you can't actually interact with the person if you go back into the past. Okay, you're in the laboratory, you get into the time machine, you go back into the past and you see yourself there. Okay, if you're using such a time machine as David is describing here, in order to travel back into the past, so it's 5 minutes past noon and you hop into the time machine and it takes you back to noon, then you will see, presumably, yourself waiting to go into the time machine. So how often can that happen? If you wait there, you're now watching this situation unfold. It's now noon and you are watching a copy of yourself. At 5 past noon, head into the time machine and go back around and go back to noon. Now, if you follow them in and you go back, presumably there will be now two of you watching what's going on. Now, as David says, quote, If I happen to be blocking the entrance to the time machine, my image will nevertheless make straight for it and walk in exactly as I did. For if it did anything else, it would be an inaccurate image. There are many ways in which an image generator can be programmed to handle a situation where an image of a solid object has to pass through a user's location. For instance, the image could pass straight through like a ghost, or it could push the user irresistibly away. The latter option gives a more accurate rendering because then the images are to some extent tactile as well as visual. There need be no danger of my getting hurt as my image knocks me aside, however abruptly, because of course I am not physically there. If there is not enough room for me to get out of the way, the virtual reality generator could make me flow effortlessly through a narrow gap or even teleport me past an obstacle. End quote. Okay, so remember what virtual reality is, okay? You're not actually there, it's just an image of you. You're just going through this experience. You've got a headset on or whatever it happens to be. So it feels for all the world like you're there, but you're not going to get hurt. Now, David considers, as I said, how often can this happen? How often can you keep on creating copies of yourself, essentially, seeing copies of yourself go in and out of the time machine? Well, as he says, quote, if I repeat the process, then after every 5 subjective minutes, an additional image of me will appear. Each image will appear to see all the ones that appeared earlier than itself, in my experience, but none of those that appeared later than itself. If I continue the experience for as long as possible, the maximum number of copies that can coexist will be limited only by the image generator's collision avoidance strategy. Let us assume it tries to make it realistically difficult for me to squeeze myself into the revolving door with all my images. Then eventually I shall be forced to do something other than travel back to the past with them. I could wait a little and take the compartment after theirs, in which case I should reach the laboratory a moment after they do. But that just postpones the problem of overcrowding in the time machine. If I keep going round this loop, eventually all the slots for time travelling into the period of 5 minutes afternoon will be filled, forcing me to let myself reach a later time from which there will be no further means of returning to that period. This too is a property that time machines would have if they existed physically. Not only are they are places with a finite capacity for supporting through traffic into the past, end quote. And let's consider why that is. In any finite amount of space, there's only so much room for matter or information, however you want to put it. We live in a physical world and there are finite parts of the physical world, so we can't just go filling up those finite parts beyond their physical capacity. There are infinities that exist, but there are also finite parts of physical reality as well. David goes on to say, quote, and this is a key point in this chapter, another consequence of the fact that time machines are not vehicles but places or paths is that one is not completely free to choose which time to use them to travel to. As this example shows, one can use a time machine only to travel to times and places at which it has existed. In particular, one cannot use it to travel back to a time before its construction was completed, end quote. And this is because you need to travel to the time machine at a particular time. If the time machine isn't already there, then how are you getting to that time and place? We're not zipping through space here like we're riding a bicycle from point to point. We are going to times where the time machine exists. Now, again, if you're disappointed by this and you think, oh no, I wanted to see the dinosaurs or wherever it happens to be and there was no time machines back in the dinosaurs, I wouldn't worry too much about that. After all, there could be natural time machines that exist already, exotic forms of black holes, wormholes, that kind of thing. And so if they're possible, if they exist, if they're not too far away, all that kind of thing, then perhaps they can be used. We don't know. There's no prophesying the growth of knowledge, so to speak. Who knows what we will discover in the future. So all hope is not lost if you want to go back and see real life dinosaurs. Getting back might be a problem though, but again, if we're thinking about far out things, we can think about far out things that don't necessarily contradict the laws of physics as we understand them at the moment. I'm skipping a bit and going to the part where David is talking about virtual reality time machine. So rather than just image generation, just going into the past and seeing stuff and the issues associated with that, let's see what happens when we try and interact with what actually happened in the past. I've already, of course, stolen a bit of the thunder here, but we shall read. Quote, if I really had access to virtual reality time travel, I should certainly want to test the authenticity of the rendering. In the case we are discussing, the testing would begin as soon as I saw copies of me. So remember, he's stepped into the time machine and he's gone back 5 minutes and he's seeing himself as he was before he got into the time machine. Let's keep going. Far from ignoring them, I would immediately engage them in conversation. I am far better equipped to test their authenticity than Dr. Johnson would be to test Julius Caesar's. To pass even this initial test, the rendered versions of me would effectively have to be artificial intelligent beings. Moreover, beings so similar to me, at least in their responses to external stimuli, that they can convince me they are accurate renderings of how I might be 5 minutes from now. The virtual reality generator must be running programs similar in content and complexity to my own mind. Once again, the difficulty of writing such programs is not the issue here. We are investigating the principle of virtual reality time travel, not its practicality. It does not matter where a hypothetical virtual reality generator gets its programs, for we are asking whether the set of all possible programs does or does not include one that accurately renders time travel. But our virtual reality generator does in principle have the means of discovering all the possible ways I might behave in various situations. This information is located in the physical state of my brain, and sufficiently precise measurements could in principle read it out. One probably unacceptable method of doing this would be for the virtual reality generator to cause my brain to interact in virtual reality with a test environment, record its behaviour, and then restore its original state, perhaps by running it backwards. The reason why this is probably unacceptable is that I would presumably experience that test environment, and though I should not recall it afterwards, I want the virtual reality generator to give me the experiences I specify and no others. In any case, what matters for present purposes is that since my brain is a physical object, the Turing principle says that it is within the repertoire of the universal virtual reality generator. So it is possible, in principle, for the copy of me to pass the test of whether he accurately resembles me. But that is not the only test I want to perform. Mainly, I want to test whether the time travel itself is being rendered authentically. To that end, I want to find out not just whether this person is authentically me, but whether he is authentically from the future. In part, I can test this by questioning him. He should say that he remembers being in my position 5 minutes ago and that he then travelled around the revolving door and met me. I should also find he is testing my authenticity. Why would he do that? Because the most stringent and straightforward way in which I could test his resemblance to the future me would be to wait until I have passed through the time machine. And then look for two things. First, whether the copy of me, whom I find there, behaves as I remember me behaving, and second, whether I behave as I remember the copy behaving. In both these respects, the rendering will certainly fail the test. At my first and slightest attempt to behave differently from the way I remember my copy behaving, I shall succeed. And it will be almost as easy to make him behave differently from the way in which I behaved. All I have to do is ask him a question which I, in his place, had not been asked and which has a distinctive answer. So however much they resemble me in appearance and personality, the people who emerge from the virtual reality time machine are not authentic renderings of the person I am shortly to become. End quote, pausing there my reflection. As I say with physical time travel, all of this is about what time you are actually travelling to, if indeed time travel is possible, and if time machines are made and you go back and see Julius Caesar, all that kind of stuff. The time you go back to is not going to be actually the time that led to your birth and going into the time machine and all that kind of stuff. Precisely because there are many, many copies. If you go back in time, meet yourself, as soon as you interact with yourself, that is a history that you were never a part of in the past. If somehow or other you could go back to 2023 and talk to yourself as soon as the conversation begins. In fact, even before that, merely by virtue of the fact that you are there in that past means it's not your past, because in 2023, there was no time travel from the future. There was no future you coming back. It's almost like one of those butterfly effect kind of things. Unless you, as the time traveller coming back to 2023, were exceedingly careful about not changing anything at all, such that it didn't affect anything, I don't know how this would be possible, then you're in a completely different universe. You're in a completely different universe in any case. But David continues to talk about the thought experiment version of time travel, the virtual reality. I want to get to the physical possibility, the reality, never mind the virtual reality, the reality of time travel. So let me put a cap on the virtual reality discussion by just reading the last section that David refers to here. So I'm skipping a number of pages here. And David says, quote, "We have seen that a virtual reality generator's ability to render time travel accurately depends on its having detailed information about the user's state of mind." End quote. It would also depend upon not just the user's state of mind, but all the information, as we say, the practicality of gathering the information in order to render the past environments as well. As David said, not really interested in that. He's interested in the physics of actually going and doing this. Let's keep going. He goes on to say, "This may make one briefly wonder whether the paradoxes have been genuinely avoided. If the virtual reality generator knows what I am going to do in advance, am I really free to perform whatever tests I choose? We need not get into any deep questions about the nature of free will here. I am indeed free to do whatever I like in this experiment, in the sense that for every possible way I may choose to react to the stimulated past, including randomly, if I want to, the virtual reality generator allows me to react in that way. And all the environments I interact with are affected by what I do and react back on me in precisely the way they would if time travel were not taking place. The reason why the virtual reality generator needs information from my brain is not to predict my actions, but to render the behaviour of my counterparts from other universes. Its problem is that in the real version of this situation, there would be parallel universe counterparts of me, initially identical, fungible, and therefore possessing the same propensities as me and making the same decisions. Farther away in the multiverse, there would also be others who are already different from me at the outset of the experiment, but a time machine would never cause me to meet those versions. If there was some other way of rendering these people, the virtual reality generator would not need any information from my brain, nor would it need the prodigious computational resources that we have been envisaging." End quote, pausing there. So, all of this is to say that if you are trying to do a virtual reality generation of going into the past, in order to see yourself, and you can interact with your past self, then it's essentially a virtual reality generator for the entire multiverse. It would have to be a quantum computer, presumably of some kind, or at least something with vast memory. Because if you're interacting with copies of yourself, those copies of yourself are faithful representations of you by having done a brain scan of all your memories and propensities, as David says. And so when you interact, the copy of you from the past would interact in the way you would have behaved, okay, you being really you, had you had that interaction from someone in the past. So for me, this is all solved by the fact that if the virtual reality generator has got a copy of you, then it's got an artificial general intelligence. It is you in one sense, namely it acts in exactly the way that you would behave. It looks for all the world like you. The only difference is that there are two copies of you. In the real world, there are infinitely many fungible copies. Skipping some more, and let's get into the real stuff as I promised. David goes on to say, quote, "A real-time machine, of course, would not face these problems. It would simply provide pathways along which I and my counterparts who already existed could meet and would constrain neither our behaviour nor our interactions when we did meet. The ways in which the pathways interconnect, that is, which snapshots the time machine would lead to, would be affected by my physical state, including my state of mind. That is no different from the usual situation in which my physical state, as reflected in my propensity to behave in various ways, affects what happens. The great difference between this and everyday experience is that each copy of me is potentially having a large effect on other universes by travelling to them." End quote. Remember that all of these different copies of you already exist. Right now, you exist as many, many, many instances, many, many, many copies. Some of which continue to do exactly what you are doing right now, some of which have gone off to do other things and everything else besides. Let's keep going. David writes, "Does being able to travel to the past of other universes, but not our own, really amount to time travel? Is it just inter-universe travel that makes sense, rather than time travel? No. The processes I have been describing really are time travel. First of all, it is not the case that we cannot travel to a snapshot where we have already been. If we arrange things correctly, we can. Of course, if we change anything in the past, if we make it different from how it was in the past we came from, then we find ourselves in a different past. Pausing there, as I was saying. So in this unlikely event that you go back into the past and you change something, then okay. No, that, in a sense, that is your past, okay? But you have to make sure that you're not seen by anyone, especially not yourself, that kind of thing. That seems highly unlikely. I think once you go back to this past universe, that's it. That is a universe in which you weren't before. Although I suppose, like you can imagine now, I can imagine as I sit here now, maybe there is, maybe I am visiting myself from like the year 2030 and I've traveled back to the past, but I'm over there somewhere watching myself recording this episode of Topcast right now. But I'm not interacting and then I disappear back to the future again. So I suppose that's possible, but that seems more unlikely. Who knows though? Who knows? Okay, let's keep going. The point is, as David has just said, quote, if we make it, the past, different from how it was in the past we came from, then we find ourselves in a different past. Fully fledged time travel would allow us to travel to the past. In other words, it allows us to make the past different from the way we remember it in this universe. That means different from the way it actually is in the snapshots in which we did not arrive to change anything. And those include, by definition, the snapshots we remember being in. Skipping a little, and David says, quote, whenever we make a choice, we change the future. We change it from what it would have been had we chosen differently. Such an idea would make no sense in classical space-time physics with its single future determined by the present. But it does make sense in quantum physics. When we make a choice, we change the future from what it will be in universes in which we choose differently. But in no case does any particular snapshot in the future change. It cannot change, for there is no flow of time with respect to which it could change. Changing the future means choosing which snapshot we will be in. Changing the past means exactly the same thing. Because there is no flow of time, there can be no such thing as changing a particular past snapshot, such as the one we remember being in, end quote. Let's just linger on that for a moment. You're choosing the snapshot to go to if time travel is possible, rather than changing the time if you go into the past. So if I was to travel into the past, if I was to go into yesterday and prevent myself from making this episode of Topcast right now, that is choosing to go to a particular snapshot, a particular past universe, where this episode doesn't get made. But that doesn't prevent this episode from getting made in this timeline, in this universe. That's already fixed. So I can choose to go to a universe where I can choose to do whatever I want. Maybe I choose to allow myself to continue on to today and nothing changes. So here I am making the episode. Or I can go into the past and prevent myself from making this episode. In which case, there do exist a whole bunch of universes where this episode never gets made because I've been prevented from doing so. Maybe those really do exist. But you and I both find ourselves in that timeline, in that series of universes where this episode has been made. Other people are having a different experience and wondering why this episode of Topcast never got made. In other words, you can't change the universe. You can make choices, but you're choosing which part of the multiverse you are going to be in. You're not changing things. That's fixed. We're not changing the past, okay? These past things have happened. They exist, including the ones where you've gone and affected things. It all gets confusing. So the word change here is somewhat problematic, as David goes on to say, quote, nevertheless, if we somehow gain physical access to the past, there is no reason why we could not change it in precisely the sense in which we change the future, namely by choosing to be in a different snapshot from the one we would have been in if we had chosen differently. End quote. In other words, this old canard, if I've got tea and coffee in front of me, and I routinely prefer tea, then the overwhelming majority of universes, I choose tea and I have tea. In some other smaller proportion, I choose coffee. Now, I'm changing the future when I make a choice, but both of those really exist. There are literally some universes, if I have tea and coffee in front of me, where I've chosen tea and where I've chosen coffee. They might not be 50-50, it could be any proportion, whatever. It depends upon my propensities, my my prior knowledge, all this sort of stuff, but there are universes where I'm having tea, there are universes I'm having coffee. I'm making the choice and I'm choosing which one I'm going to experience consciously. Copies of me will have other experiences, and some won't just be those two choices either. As I say, in some of them I'll be struck by an asteroid, whatever. Things that are possible according to the laws of physics will happen. David goes on to say, quote, "Arguments from virtual reality help in understanding time travel because the concept of virtual reality requires one to take counterfactual events seriously. And therefore, the multi-universe quantum concept of time travel seems natural when it is rendered in virtual reality. By seeing that past-directed time travel is within the repertoire of a universal virtual reality generator, we learn that the idea of past-directed time travel makes perfect sense. But that is not to say that it is necessarily physically achievable. After all, faster-than-light travel, perpetual motion machines, and many other physical impossibilities are all possible in virtual reality. No amount of reasoning about virtual reality can prove that a given process is permitted by the laws of physics, though it can prove that it is not. If we had reached the contrary conclusion, it would have implied via the Turing principle that time travel cannot occur physically. So what do our positive conclusions about virtual reality time travel tell us about physics? They tell us what time travel would look like if it did occur. They tell us that past-directed time travel would inevitably be a process set in several interacting and interconnected universes. In that process, the participants would in general travel from one universe to another whenever they travelled in time. The precise ways in which the universes were connected would depend, among other things, on the participant's state of mind. So, for time travel to be physically possible, it is necessary for there to be a multiverse. And it is necessary that the physical laws governing the multiverse be such that in the presence of a time machine and potential time travellers, the universes become interconnected in the way I have described and not in any other way. For example, if I am not going to use a time machine, come what may, then no time travelling versions of me must appear in my snapshot. That is, no universes in which the versions of me do use a time machine can become connected to my universe. If I'm definitely going to use the time machine, then my universe must become connected to another universe in which I also definitely use it. And if I'm going to try and enact a paradox, then as we have seen, my universe must become connected with another one in which a copy of me has the same intention as I do. But by carrying out that intention, ends up behaving differently from me. Remarkably, all this is precisely what quantum theory does predict. In short, the result is that if pathways into the past do exist, travellers on them are free to interact with their environment in just the same way as they could if the pathways did not lead into the past. In no case does time travel become inconsistent or impose special constraints on time travel's behaviour. Pausing there, my reflection. Now, there is a little bit more to say here. The most important part of the chapter is about to come. In fact, I'm going to leave this as a cliffhanger. There was so much to say about the final part of the chapter that it needed an entirely new episode. Until then, have fun and stay optimistic.